Now we will finally talk about how to install software on our system. Let's start with what's an installation. Installing a software in our computer means that we are making it ready for being run on our system. In the low level, how this is exactly done is dependent on your particular computer architecture and the current exact state of the already installed software in your system. However, much of this is nicely abstracted away by convenient tools we use for installation. You may also hear a lot about installing libraries. A library is a collection of pre-written software that a program can use. There are several routines that are shared by many programs. For example, many C programs need to use standard read and write routines of the C language. Therefore, instead of writing the same code of frequently used routines inside every program, we collect them in a C library that every C program can include and use. To be able to use it, this library must already be installed in our system. Typically, when we are using task-related software, for example, when you are using language processing software that not a lot of people use, you may need a library that doesn't come installed by default. In that case, you need to install the library yourself. The same is also true when developing programs ourselves. Since not everyone writes code in their computers, some of the libraries that are necessary for development don't come installed by default, and you may need to install them explicitly. For installing a program or library, you may be required to install some other software, typically some libraries first. These prerequisites are called the dependencies. Typically, a program or library has dependencies exactly because of the reuse logic that we have been talking about. There is some common code that is already packaged up in another library, and the one you want to install requires this functionality. So instead of writing everything up again, it just makes use of this other existing library. For example, a deep learning library may depend on an optimization library for training the model, which can in turn depend on a linear algebra library, which can in turn depend on a matrix library. Typically, any useful software depends on dozens of libraries, which would likely depend on dozens of libraries themselves. The most common of these would already exist in your system, but the more fringe ones likely wouldn't. Or their versions might be old, for example, and they may need to be updated before you can use your software correctly. Commonly, installing something new may require installing or updating a huge number of dependencies first. This can get really complex, since this dependency software may have its own dependencies, which in turn will have their own dependencies. So, with this never-ending chase of dependencies, installing a high-level software would typically become quite a challenging task before the 2000s, when we started using package managers to handle things for us. A package manager is one of the greatest inventions of the century. When you are using a package manager to install stuff, either a program or a library, the package manager does the magical job of installing also the necessary dependencies for the software. Examples of package managers are apt-get for Debian-based Linux systems, including Ubuntu, and Homebrew for macOS, and for example Conda for Anaconda distribution. When you try to install a software using a package manager, it first analyzes the necessary dependencies for the stuff you are trying to install by starting from its dependencies, then analyzing the dependencies of these dependencies, and in this manner tracing the dependency tree backwards until they get a list of all the necessary packages. Then they install or update all of these dependencies, starting from the most basic one and proceeding forwards until all of the dependencies are correctly installed. Finally, it installs the required software. Let's install some software with a package manager then. The package manager we will use, if we are using a Linux system, will be apt-get. For the Mac OS system, it will be Homebrew. So I will be using the command brew. Please exchange this command with apt-get if you are working in a Linux system. Let's install ImageMagick. In our system, ImageMagick is a program for converting image files to different formats. I will first pretend that I'm using a Linux system and I will run the commands. They won't run as they should on the Mac, but I will go through the commands anyways. For Linux, we will be using apt-get. When using apt-get, from time to time you need to update it, which means make it receive information about newly available software and newly available versions. It's good to get into this habit, so let's do this updating first. So we will use the command sudo for using the root privileges with apt-get. This is not going to run properly in my system. In the Linux system, you need to provide your user password for sudo, and then update will make apt-get receive the new list of packages that are available now. Then let's proceed to the installation. We will again use sudo and apt-get, this time with the keyword install and the name of the package. Again, using your user password, this command is supposed to do all the installation magic for you. In Mac, a comfortable option to use as package manager is Homebrew. Homebrew doesn't come out of the box with macOS because it's a community developed package manager. It needs to be installed separately first. You may remember that we installed Homebrew at the beginning of the course so that we could install wget using it. The command for running Homebrew is shortly brew. Differently, we run brew without using sudo, but it may ask for our password during the process. Brew also does its updating automatically, so we don't need a separate command for updating the package list. The command that we need to use in Mac is brew install ImageMagick. And now let's see how the installation progresses. So there will be this updating process first, which we did explicitly in apt-get. Now, see that it has found some dependencies for ImageMagick. All these libraries, they are needed, but they don't exist in my system. And brew and apt-get is also going to do the same thing. Downloads them one by one, installs them, and lets me know if installation or downloading anything succeeds or fails. For now, it seems everything is going fine. There are some 100%. I don't see any errors. Downloading is successful. And after it has finished installing all these dependencies, finally here it downloads and installs the ImageMagick software itself. A similar sequence is going to happen also in Linux using apt-get. It will check the dependency list, install all these dependencies one by one, and finally it will install the software. If there's a mistake in any part of this process, either installing of the dependencies or installing of the actual software, then it will issue an error. Now we have installed new software. What happened in my system? New files must have appeared. Let's try to find them and see what kind of files they are and where they have been placed. In general, there are two ways of searching for files that we don't know where. One is a fast way and one is a slow way. So the slow solution is to use a combination of the commands find and grep that we have been using up to now. If, for example, I go to the root of my system, and from here I issue a find command that is going to list all the files recursively until under root. That will be all the files in my system. And I grep for my keyword of interest, for example here ImageMagick list. So here I see an installation, which has a bin directory, bin holds the executable files, which has an include directory. If you are writing or have written program in C or C++, you will be familiar with the concept of header files. The C programs have a component called a header, which is the description of a software, and these will be put under some kind of include directory in general. There is a etc directory here, which holds typically the settings, and there's a lib directory which holds the libraries that come with ImageMagick, also including its own library that can be used by other programs which want to have access to ImageMagick functionality. These are all put under some USR local folder. This is historically used a lot when we install software. This seller is something that's introduced by Mac, so I only see it in a Mac installation, and the Unix users are not going to see them. So we have seen a lot of files here. Find is still continuing to find things. It is quite slow because it goes through all the files in the system one by one. There are a lot of files in my system, so this is going to take some time. Let's open a new terminal. There's a faster way which works on a maintained database of existing file names and searches only over this database. So it's much faster than going through the files one by one, because it just goes over the database instead. This is using the locate command. But for using the locate command, we need to first build a database. For this, in Mac, we will need to use two commands. You can copy and paste from the script for this week. And this is going to load this service if it hasn't been already loaded in your system. If you give this command once, then you won't need to give it again. The second one is for updating the library. So typically after installing something, we need to update the list of files in our system. This is the Mac version of commands, and in Linux the commands we are going to use are different. First of all, you don't need the first one. For updating, you will need a different command. It's the update db command, and you don't use all these headers, but just say sudo update db. And finally, the third command, the locate command, is going to be same between the two systems. So updating the database will take some time if it is the first time to update it. This update db, similarly, when you run it for the first time, it will take a long while, but for the second and third time and so forth, since the database will already have been readied, then it won't take as much time. When the update commands have finished running, then we can search for ImageMagick using the locate command, and let's again pipe it to less, and this works much faster. As I have mentioned shortly, three kinds of files are typically installed. These are installed under some conventional places generally, but that can change. Most of these conventional locations are historically motivated, but it's good to know some of the keywords. The first keyword is bin, short for binary, where the machine executable files are put. This can be something like a USR local bin, or in this case, for example, USR local seller, because this is a Mac ImageMagick version number bin under which we find all the binary files. This is good to know if you are looking for the path of an executable file. Header files for C programs will be put under some kind of include directory. Setting files will be under etc, and libraries that come with the software will be under a lib directory. So an installation, depending on what you are installing, can add one or more types of these files in your system. Since these locations are just general guidelines, we must generally search for files if we want to know exact locations. So in a forum, for example, you may see that, oh, this file must be under this and this bin directory, but maybe you may not be able to find that file exactly there. So you can search. Generally, you will find the same file under a similar directory, for example, a bin directory that's in a slightly different position. Thank you for listening. This is all for this video.